Swayam Prabha. Digital India. Educated India.
Discussing the module 7 of the organic chemical technology course, and we discuss about the polymer industry, different type of the polymers. Today we will be discussing about the elastomer, means the natural rubber and the synthetic rubber, and the next 2-3 lecture that will be on the synthetic fiber. So, the coverage of the lecture, that will be the introduction, various synthetic rubber and monomer, styrene butadiene rubber, which is one of the most widely used rubber, natural and synthetic rubber historical review, polybutadiene, polyisoprene, polycropene, hyperylene, spandex. These are some of the other synthetic rubber that we are making. I will go very quickly on this polyisoprene, polycropene or the hyperylene. We will be discussing in more detail about the synthetic rubber and the polybutadiene. Why the importance of the polybutadiene? You know, the polybutadiene in the petrochemical complexes, we are having the cracker plant. So, the butadiene, one of the very important feedstock for making for the which we are getting from the C4 steam of the your cracker plant, and this is the reason why the Reliance and the even the Haldia refinery, where they are having naphtha cracking, they are recovering the butadiene, and in case of the Reliance Hajra, they are having the polybutadiene plant, and IOC Panipat refinery, they are going to have the SBR plant. This lecture 4 will be all in the elastomers, styrene, butadiene rubber, polybutadiene, nitrile rubber, and some of the other specialized rubbers which I discuss here. Elastomers are used in variety of industrial, medical and household products, and major portion of the elastomer consumption goes into tire. Next largest product sector is the latex goes, and you see the importance of the elastomer or the rubber. When a child is he start walking and playing, so first he start playing with a ball, and that ball is from the synthetic rubber. And so there has been revolution in case of this synthetic rubber manufacture all over the world because of the coming of the large number of the petrochemical complexes and the availability of the raw material, which was earlier through the non-petrochemical route. There are two major type of the elastomers, that is the one is based on the natural rubber, a product of the tropical tree, heva, brasilins, and the synthetic rubber, a family of materials derived from the petrochemical. So, these are the some of the tropical countries, they are producing the natural rubber. India is also one of the major natural rubber producer, but in synthetic rubber that is playing in the important role, and that is the important part of the elastomers. Major producer of the natural rubbers are natural rubber producing country are Thailand, Indonesia, Malaysia, Africa, Latin America, Brazil, Cambodia, Nigeria, Sri Lanka, Thailand and India. Demand for the natural rubber is estimated to have been around 10.9 million tons in 2011, out of which around 45% was from Asia. So, this is the, you can see the some of the country which are producing, they are the Asian country which are making huge amount of the this natural rubber. Let us discuss some of the historical background, because this is the, so far the elastomer or the rubber is concerned, this is not the from the ancient time. Even in the 1525 you see the elastic ball reported by Mexico tribal people, that was the 1735 first scientific study of the rubber by Charles de la Condamine, and then the 1820 first planting of the rubber in India at the Travancore, that was started. 1832 Rossburg factory was set up for rubber goods with non-vulcanized rubber, because the one of the, in case of the rubber uses the vulcanization of the rubber which you are doing in case of the tire where the vulcanized rubber that is being used. Methyl 1914 methyl isoprene rubber in Germany. 1845 that was the pneumatic tire that was introduced. First commercial plantation 1903. First large scale commercial production of butadiene rubber, that was 1910. 1914 to 80 methyl isoprene rubber in Germany. And you see the lot of the development earlier also I told you that during the World War I and World War I and World War II, lot of the development took place in case of the chemical industry, just to the rising demand which were also required from the war point of view, and so that led to the development number of the your petrochemical important petrochemicals. So, methyl isoprene rubber in Germany, that was in 1940. 1930 organic polysulfide rubber, neoprene production started in 1931. 1932 first synthetic rubber plant in USSR, and 1930 Bunayas made in USSR. As you know, the Dunlop, now there are other players also, they were making the tire, Modi rubber and other seat, and so number of the plants are now there. But first it was in 1936 first automatic tire factory by Dunlop, that was started in India. 1963 first synthetic rubber plant in India, that was I told you earlier also by discussing the raw material and the petrochemical, because synthetic chemicals and Bareilly, that was the first non petrochemical route plant which was started in Bareilly, but due to some other reason that unit is now closed. But that was the first plant where the molasses and that was the molasses to ethanol and ethylene, butadiene, all those products they were made from the your molasses route. 1976 first nitrile rubber by synthesis chemical. 1978 first polybutadiene plant in India by IPCL, now Reliance at Vadodara. That was the, because you see the Reliance Vadodara unit, earlier it was the IPCL, that is one of the largest, you can say the integrated petrochemical complex where about 18 to 19 plants are there. Although at that time the capacity that was okay, but in the now all those capacity are not at the world level, and so the plant capacity less in all those units. Reliance Industry Hajra, they started manufacturing polybutadiene, and now the IOC Panipat SBR plant in the pipeline, and so certainly there will be, that is in the action phase. So, SBR plant that is coming, where they will be using the butadiene from the cracker plant, and then the styrene they will be making, their ethylene they will be using. So, that is the new plant that is coming at the IOC Panipat refinery. Now, let us discuss about the synthetic rubber. Synthetic rubbers have slowly replaced the natural rubbers and have undergone various development for application in automotives, chemical industry, because automotive is the one of the major consumer of the rubber. Chemical industry, we are having the, you are using the rubber lining of the equipment that is being done. In various other application appliances also we are using the rubber goods. So, energy generation, sports, aerospace industry, these are all where we are using the synthetic rubber in some or other form. This is the how the development in case of the natural rubber and the synthetic rubber that has taken place. So, let us discuss the what are the various type of the synthetic rubber that is available. So, first is the major is the styrene butadiene rubber, the second is the polybutadiene rubber, because in case of the SBR we need the ethyl benzene and ethyl benzene to styrene. So, in case of because the polybutadiene also one of the very important your rubber. So, the Reliance they are making the polybutadiene, not the SBR. Another important that was the nitrile rubber with the where the butadiene and acrylonitrile rubber, because that was again requirement of the time during World War sealant, because the oil resistance towards the oil. So, this was the one of the very important development during that with nitrile rubber. Vinyl pyridine styrene butadiene rubber, butyl rubber and the chlorobutyl rubber, polyisoprene, that is because the isoprene now they has a, while discussing the C4 C5 discuss the isoprene about 8 to 10% that is available from the C5 stream of the cracker plant. So, the or the FCC, so that can be recovered and that isoprene can be made available to the synthetic rubber enzyme. So, that is the how the otherwise the natural source is of course there. Vinyl pyridine butadiene rubber, nitrile chloropene, various combination of the your monomers are there. Then the styrene block polymer SBC, that is also one of the very important outlet for the styrene. Ethylene propylene rubber EPDM, chloropene rubber, fluorocarbon rubber and the silicon rubber, that is also one of the very important class, and the polyacrylate rubber, polysulfide rubber, urethane rubber, latex and foam. So, these are the some of the broad range of the synthetic fiber that we are making, but among all these SBR, polybutadiene and the nitrile rubber, these are the very important synthetic rubber that is being that is having the wide application in the industry. These are the some of the monomer that we are using: ethylene, propylene, butadiene, isobutylene. So, these are all the products you see the we are getting through the now with the petrochemical isobutylene also, that is while discussing C4 I told you the MTB, and that can be cracked at the your hydration, that was the another route. So, that will be just will be getting the isobutylene and the for the rubber grade permeation gets high purity isobutylene from the cracker plant, or it may be the from the C4 stream of the cracker plant at the FCC. So, that is also, so all these four, again the styrene also we need the ethyl, ethylene, benzene, this all that you can get from the petro. Even in case of the cracker plant itself you can get the benzene and the ethylene and then ethyl benzene, and then again the development of the alkylation process, the development the catalyst has led to the manufacture more and more manufacture of the styrene. Another important feedstock that the acrylonitrile, isoprene of course, and that I told you that the isoprene, that is one of the, again it is available from the C5 stream. Acrylonitrile, because you see the acrylonitrile earlier it was made from the acetylene route, which I told you the while discussing the petrochemicals, but acrylonitrile now that is available through the propylene route, which is being now the most of the acrylonitrile that is being. So, that has also played important role in providing the feedstock for the synthetic rubber industry. This is another very for the silicon rubber dimethyl iloxane, that is the another for the silicon rubber, sodium tetrasulfide ethylene dichloride, dicol they are very using, and the polyester the polyether for the urethane rubber. So, these are the some of the important monomer for this synthetic rubber industry. This is the importance of the rubber which I told in the automotive sector, because huge amount of the rubber that we are using in case of the automobile industry. So, one of the major consumer is the tire. You see the whether it is the two-wheeler, three-wheeler or the four-wheeler, you need the tire. And so, the tire, and even in the tire now we are having the tubeless tire, or the earlier it used to be tube in the tires. In all the cases that we need the rubber. So, that was the one of the major, and the chain, belt piles, side walls, carcass, inner, grommet, bumper, hose, bushing, fan belt, damper. So these are the some of the actually the so for the automobile sector where the application of the rubber is there. Now let us discuss about the styrene butadiene rubber, which is one of the most widely used elastomer in the world because of the availability, because of the flexibility in the raw material, either from the molasses route or from the petrochemical. So styrene butadiene rubber is known as BUNAS also. There has been significant development in the process technology of styrene butadiene rubber manufacture. Amongst the various processes which we are using, emulsion polymerization of the styrene butadiene rubber is most commonly used method. The cold process of the emulsion polymerization has been replaced with the hot polymerization process. And as I told you, in India the first SBR styrene butadiene rubber manufacture was started by Synthetic and Chemical Styrene in 1963. The unit is now closed because of their own problem, and although the butadiene, because the another important for the styrene butadiene is the rubber is the butadiene raw materials. Although butadiene again is recovered from the cracker plant, it can be also made from the ethanol route. Styrene is made from the ethyl benzene by alkylation of the benzene with ethylene, which can be also recovered from the FCC. As I told you that now the interest is there, why not to recover that ethylene which is available in the FCC gases. Although the amount of the ethylene that is less, it is below 10%, but that can be used for the alkylation process. And now the technology are available for the direct FCC gas containing ethylene that can be used for the making of the styrene butadiene rubber. Means the styrene. Styrene means the ethyl benzene, it will be first and then the styrene. So styrene butadiene rubber is made by emulsion polymerization at 50 degrees centigrade. Initiation occurs through reaction of potassium peroxide disulfide with N-dodecyl mercaptan. So the chain propagation occurs by growing chain free radical of mercaptile attaching either butadiene or styrene. The reaction is terminated at around 60 to 75 degrees centigrade, 60 to 75% of the completion of the reaction. Unreacted butadiene and styrene are recovered. So other actually additives are also added. Antioxidant is added, followed by coagulation, washing and the drying. It is used as elastomer, emulsion and solution, used in the tires, tire related product, mechanical goods, automotive use, adhesive and the shoe products. Another important actually that is the polystyrene butadiene, and that is the SBS. SBS is a hard rubber which is used for the soles of the shoes, tire treats and other places where durability is important. Now you see the earlier we used to have the shoe soles made of the leather. Now with the coming of the synthetic rubber and the urethane rubber especially, a lot of the durability of the earlier we used to have the cracking. So durability is much longer of the shoe. So this is one of the another actually the advantage in case of the synthetic rubber. It is a type of the copolymer called a block copolymer. This is the process for the manufacture of SBR. The styrene butadiene that is going to the monomer tank mixing and the polymerization reactor, where the reaction that is taking place, and as I told you this after the completion 75 conversion, that is going to the monomer recovery, where the monomer again it is recovered here, that is going to recycling and you are getting the latex. As such it can be used, or it will go for the coagulation, then the styrene butadiene rubber drying and the baling that may be done. So this is the process for the manufacture of SBR. was talking about the SBS. Its backbone chain is made of 3 segments. Uh, First segment polystyrene, second polybutadiene, and third is the polystyrene. So, this is the combination of styrene, polystyrene, butadiene, styrene. So, polystyrene is a tough hard plastic and this gives SBS its durability. Now, let us discuss about the polybutadiene, because this is another important derivative of the butadiene also, and at the same time one of the important your synthetic rubber. So, before going for in detail about the polybutadiene process, let us discuss what are the sources of the butadiene. Although I have discussed this while discussing the petrochemical, the butadiene steam cracker is major source of butadiene. Other routes for butadiene are catalytic dehydrogenation of the butenes, catalytic dehydrogenation of the butane. So, these are the two other, and this because these two we can recover from the FCC gases, the C4 gases. This is the reason why the C4 gases of the cracker plant as well as the FCC, they have become very important source for the value addition to the refinery or the petrochemical complex, which was not being done earlier. So, in future we may have the more and more utilization of the C4 and C5, especially some of the raw material which will play important role in the development of the synthetic rubber industry. So, with the availability of the polybutadiene, as I told you, and in the cracker plant, manufacture of the polybutadiene has increased significantly in the recent year, because we are having now the large capacity cracker plant naphtha. Earlier, as I told you, and during the naphtha cracking, we started in only 20,000. Now we are having 8 lakhs ton plus 8 lakhs ton capacity naphtha cracker plant. So, amount of butadiene that is generated very high, and so that has led to the development of the either SBR or the polybutadiene rubber. So, for the process concerned, polybutadiene is made by free radical emulsion, alkali methyl solution, and the transition metal coordination solution process. Most processes are based on the solution process. Large volume use of the polybutadiene rubber has been primarily in blend with the other polymers. Blend with the SBR or natural rubber has improved the crack resistance. Cracking and abrasion resistance is very good in case of the polybutadiene. It is characterized with high abrasion and the crack resistance, better resistance to heat degradation and the blowouts, good hysteresis properties, large scale use in the tire cord, modification of the plastic, conveyor and the V belts. Again the conveyor and the V belts now for the transportation of the raw material in the industry. Lot of the number of the belt conveyors we are having, and many equipments we are having the V belts. Sports coat, because that is also one of the major consumer, all the amount that may be less if you compare with the other users, but that is also one of the, and even the sports from the, if you see the sports, even the football which you are saying, or the balls which you are getting now, there is a lot of the changes in the raw material configuration. Footwear, that is also one of the important consumer of the polybutadiene, and the of course that is the tire industry. Polybutadiene rubber is made by the polymerization isobutylene. As I told you, the isobutylene can be recovered from C4 steam, from steam cracker and the FCC. Other route for isobutylene are dehydrogenation of isobutene and N-butene, isomerization in gas phase using the platinum catalyst. The polymerization is carried out in slurry of the monomer in methyl chloride using an aluminum chloride catalyst at 100 degree to 90 days. the rubber is precipitated by adding water and finally washed and dried. Butyl rubber has unique elastomeric qualities, low rate of gas permeability, thermal stability, good ozone and weathering resistance, vibration damping and higher coefficient of friction, chemical and moisture resistance. Used in the tubes, tire liner due to low permeability of air, automotive, mechanical parts, adhesives and sealant. So, these are some of the major application of the polybutadiene rubber, and so this is one of the very important properties, the low permeability of the air. Another important class of the synthetic rubber is the nitrile rubber, which I told you that is the combination of the acrylonitrile and butadiene, and the both earlier as I told you the starting phase of the nitrile rubber that was through the non-petrochemical route. So, acrylonitrile and butadiene copolymers are commonly known as the nitrile rubber. Acrylonitrile 18 to 15% with increase in the acrylonitrile resistance to, and this I was telling the oil sealing, because the oil leakage resistance to the oil leakage in case of the nitrile rubber is very high. So, the resistance to oil, fuel, abrasion and heat increases, higher tensile strength, hardness, gas impermeability. So, these are the, if you are increasing the acrylonitrile content, so the effect will be the more resistance to oil, fuel, abrasion and heat. Low temperature resistance, resilience, plus plasticizer compatibility decreases, requires less sulfur, more accelerators than SBR, highly oil resistance. These are some of the characteristics of the nitrile rubber. Application: fuel hose, collapsible containers. Nitrile rubber may be reinforced by phenolic resins and PVC. Resistance to ozone, weathering, better gloss, bright color, high resistance to abrasion and oil. A basic polymerization recipe in addition to the monomer contains water, stabilizer, emulsifier, salt stop catalyst, activator and electrolytes. A free radical generating catalyst is added and the mixture is agitated. Following polymerization cycle, material is transferred to the blow down tank in which the salt stop and the antioxidants are added and residual monomer are recovered, and which is again recycled to the reactor. Finally, the latex is concentrated as others while discussing, we discussed the, we can have in the latex form which can be coagulated, washed, dewatered and finally dried. Nitrile rubber is used in seals, O-rings, gaskets, oil filled parts, diaphragm, gloves, belts, wire cable, insulation, hose pipes, footwear, shoe products, molded rubber goods. Now discuss another important class of the synthetic rubber, that is the polyisoprene. That was the actually the importance in case of the recovery of the isoprene from the C5 acid. So, polyisoprene is one of the most well known natural elastomer derived from the Havana tree, because you see the isoprene, that is the part, but that is the natural rubber, that is the what we are having. But synthetic polyisoprene is also possible, and so that is made by the polymerization of the isoprene, which can be recovered from the C4 C5 gas, from the C5 gases, because after recovery of the C4 gases that will go to the isoprene, and there actually some problem in separation because of the close boiling point and the liquid extraction, that we are separating the isoprene, and that is the isoprene that can be used in that from the, if you are going from the C5 route, from the C5 gases. So, isoprene polymerization is carried out in an inert hydrocarbon solvent, aliphatic solvent, basic steps involved in case the manufacture of the polystyrene are raw material preparation, purification, polymerization, catalyst deactivation and removal, solvent recovery, polymer drying. So, these are the basic steps involved in the manufacture of polyisoprene. Another important class of the synthetic rubber, that is the neoprene polychloropene. Polychloropene is made by emulsion polymerization processing using resin acid soap emulsifier. Polymerization is carried out at 40 degrees centigrade in presence of the sulfur. Some of the major applications of the polychloropene is in adhesive, transportation industry, wire and cable, construction industry, hose and belting. Usage: adhesive, transportation, automotive gaskets, V-belts, shock absorber covers, wire jackets, molded seats, aviation wire cable, gasket seats, etc. Rail brake hose, track mounting. So, these are some of the major application of the polychloropene. Chloropene, again here also the same acetylene route is available. So, that can be made from the acetylene or the butadiene route, because earlier when the butadiene was not from the petrochemical, so acetylene, that was the route for making of the chloropene. So, acetylene route involves dimerization of the acetylene to monovinyl acetylene followed by reaction of monovinyl acetate with HCl. So, this was the method that was developed earlier with for the acetylene route. So, polymerization in case of the neoprene, that is polychloropene, is carried out at 40 degrees centigrade in presence of the sulfur. Some of the major application already we discussed about the polychloropene, that the adhesive, transportation industry, wire and cable, construction, hose and belting. Chlorobutyl rubber. So, here chlorobutyl rubber is made from the isoprene and isobutylene and 1,3% the isoprene, introducing a continuous system of chlorine gas in hexane, because along with this isobutylene and isoprene, chlorine that we are using, so the introducing a continuous system of the chlorine gas in hexane solution of butyl, which is prepared by low temperature copolymerization of the isobutylene and isoprene. Methyl chloride makes the chlorobutyl. So, this is the process we are using for making of the chlorobutyl rubber. What is the advantage of the chlorobutyl? Chlorobutyl rubber possesses greater vulcanization, because that is one of the major part of the process when you are using the rubber and the tire, vulcanization of the rubber that is being carried out. So, the vulcanization, flexibility and tubeless tire. Now, the most of the new breed of the cars will find you are having the tubeless tires. So, tire side wall components, heat resistant struck inner tubes, hose pipes, gaskets, conveyor belts, adhesive, sealants, tire curing bags and the tank lining, etc. So, these are the some of the uses of the. Now, let us discuss about the silicon rubber, that is the polysiloxanes. The silicon elastomers are made by ring opening reaction caused by action of alkali on monomer acrylic siloxane, characterized by exceptional mechanical and electrical performance under extreme temperature condition. So, this is one of the very specialized rubber, you can say, and we discuss about the, while discussing the polymer elastomer and the synthetic fiber, how we are doing the, one is the your special elastomers and another was the which we are using commonly used elastomer. So, this is coming in case of the specialized elastomer. So, because of the exceptional mechanical and electrical performance under extreme pressure, it is used in the aerospace appliances, electrical industry, construction industry, automotive industry, gasket sealing, spark plug boards, hose, rubber rolls. So, these are the now one of the another actually I told you the rubber importance of the rubber, that is the calendaring and other we discuss by discussing the paper, the press rolls or the final MF this glaze mush rolls was there. There we are using the rubber line rolls are there, that is available. So, even some of the chlorine application we are doing the lining with the chlorine also of the. So, this is the about the not only about the silicon, but it was the another major application of the synthetic rubber. So, this is the so far the silicon rubber is concerned, this is used in aerospace appliances, electrical industry, construction industry, automotive industry, gasket lining, spark plug boards, hose, rubber rolls. Fluorosilicon rubber, this is another specialized rubber, is characterized by its excellent low temperature flexibility, very good heat resistance, excellent aging characteristic. However, it has poor resistance to aromatic hydrocarbons and common polar solvent. So, this is the another class of the synthetic rubber. Polyurethane rubber, this is made by reacting polyisocyanates and polyhydroxyl groups using curing agent. Good abrasion resistance, oil and solvent resistance, oxygen, ozone resistance, and the temperature resistance. So, this is the actually the some of the characteristics of the polyurethane rubber. Another very important class of the your specialized elastomer is the ethylene propylene. This is made by the ethylene propylene rubber, that is the it is made by polymerization of the ethylene propylene diene in using Ziegler type the catalyst in combination of the transition metal halides and the metal. Adding polar material means water stops the polymerization, unpolymerized monomers are recovered and rubber is separated from the solvent by steam. Rubber flocks are, because of the flocculation that we are carrying, the rubber flocks are crumb are dewatered and dried. So, this is about the ethylene EPDM. EPDM has outstanding resistance to heat, ozone oxidation, weathering and aging due to the saturated backbone, low brittle point, glass transition temperature, low density except the aliphatic. Another class of the synthetic rubber is the hypalon. Hypalon are the chlorosulfonated polyethylene and are made by free radical catalyzed reaction of the chlorinated and SO2 with polyethylene. So, hypalon is characterized by ozone resistance, light stability, heat resistance, weather ability, resistance to deterioration by corrosive chemicals, weather ability, resistance to the deterioration of the corrosive chemicals, good oil resistance, flame resistance and the toughness. So, these are the some of the important characteristics of the hypalon. These are the some of the in case of the hypalon automotive car liner coatings, spark plug boards, primary and ignition wire, tarpaulins that we called it for the lining that sometimes we are using. Earlier it was very common use of the tarpaulins for the hose, conveyor belt, coated fabrics. Another class of the synthetic rubber, that is spandex. Spandex is a polyurethane elastomer which has both urea and urethane linkage and has hard and soft blocks in its repeat structure. Polysulfide rubber. Polysulfide rubber has outstanding resistance to oil, gasoline and solvent, good resistance to weather, ozone and sunlight, excellent impermeability to gases and vapor. It has poor resistance to abrasion, tear cut growth and the low tensile strain. Ethylene vinyl acetate rubber, EVA, which is very commonly known as EVA. EVA has excellent resistance to, because this was the availability of the vinyl acetate. EVA has excellent resistance to heat, ozone and sunlight, moderate resistance to oil and gasoline. It has poor resistance to aromatic and oxygenated solvent, fair processability. So these are some of the advantages and the EVA, that is the also one of the specialty. So this was all about the elastomer and the various type of the some of the elastomer I could not discuss in detail, but in the next lecture will be now on the three lectures of this module, that will be on the synthetic fiber industry, where we will be discussing about the first phase about the caprolactam, nylons, nylon 6, nylon 66, then it will be on the terephthalic acid, purified terephthalic and polyester. Another lecture that will be on the acrylic fiber, and the last lecture that will be on the viscose rayon, acetate rayon and the cryptoammonium rayon, because that is also one of the very important sector of the synthetic fiber. So introduction of the synthetic fiber, raw material and other aspect that will be discussing in detail in the next lecture.